Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today's topic of discussion is about acetal. So actually it is not acetal, it is actually ketal, but sometimes people call. Now, so you have to say after this reaction what is the major product. 4 options are provided and one of them is the right answer. This problem is pretty easier. I request you please pause the video, try by yourself, and whatever answer you get please write in the comment box along with few words as explanation. And don't hesitate whether your answer will be right or wrong, because self-evaluation is essential for improvement and that's why you should try. I believe you have tried by yourself, so it's my turn to give you the right answer. So you can see here that this molecule is actually ketal. Obviously it is you may consider protection of these 1,3-triol, and not only that, this molecule has 3 asymmetric centers or chiral center. This is the thing. Apart from that, it has actually a double bond. And if you look at the condition little carefully, copper acetate 0.2 equivalent means catalytic, 10 mole% palladium chloride, oxygen, and this is acetamide water. What do you mean by acetamide? Acetamide is the higher on analog of formamide or NN dimethyl formamide. Okay, so this is analogous, higher analog of DMF, so it's actually solvent here, and along with that some amount of water is taken. Now, so simply you can understand what is this reaction. This is nothing but Walker's process. Okay, I've already discussed dedicated lecture on this, but that may have some technical issue, that video voice thing. If you want, you can visit. Now, obviously in Walker process, what is the product? Obviously carbonyl compound. Now let's see what is produced here. Now here first step is actually coordination of these alkene to this palladium to produce this coordinated species. Now this double bond electron is donated to palladium center. Obviously what will happen? This double bond carbon will have some electron deficiency, so we can consider that this is delta plus, and obviously this carbon is also delta plus. But who has more positive charge density? Because if you look at this is actually not symmetrical alkene, so this side here there is a carbon-carbon bond, this part, so actually it can donate electron by plus I effect. So you can expect that this position have slightly more excess of positive charge density, and that's why what will happen, the nucleophile here, obviously water molecule, will prefer to attack this center. Okay, so after attack and then release one proton, because after attacking this oxygen will have a formal positive charge, it will form this OH. Fine. Now this is alpha carbon, this is beta carbon, this beta hydroxy derivative. Now in the next step what will happen? Beta hydrogen elimination. This hydrogen will be eliminated. How? So you can consider that these will attack 4-member ring type reaction and it will produce this alkene. This is a pi bond forms here, so it's an alkene. So you may consider this part, if you look closely, this is actually enol. Okay, and actually during this process palladium is reduced to palladium 0, and that is oxidized by copper 1. So 2 molecules of copper 1 needed, and it oxidizes palladium 0 to palladium 2, and copper 2 salt and copper got reduced into copper 1, and this copper 1 is got oxidized again by oxygen, so that's why oxygen was given. Now, so this is enol, and we know enol is relatively more stable compared to keto form, and it undergo tautomerism to produce the keto. I have already discussed a dedicated lecture on this keto enol. Tautomerism you may visit for better understanding. So this is tautomerism. Now, so this part we understand. Now a simple confusion may come that, sir, previously we have studied that Walker reaction of ethylene resulted in acetaldehyde, but why this is? Student, remember one statement: if you have any alkene apart from ethylene, means for example propylene, then the product will be ketone. Okay, so in this case it will be acetone. So that thing you remember, and it was not ethylene starting, it's a substituted alkene, so it will produce a ketone at this position. Just remember that much is enough. So actually this is a simple Walker reaction to produce this carbonyl. Now second question may come in your mind, that sir, here there is one acetal means ketal protection. Why it didn't break? Actually student, if you say the medium is almost neutral, or you may consider mild acidic, because palladium chloride may react with water and some part will undergo hydrolysis to produce slight amount of HCl, but that is not enough to hydrolyze this obviously ketal. So that's why you can expect that this reaction didn't happen. And another thing, it's actually 1,3-diol, so acetal is relatively stronger. Okay, cyclic one, that's I mean. So that's why this hydrolysis will not happen. So this will be the product. And by the way, if you were to know the actual mechanism of this Walker process, you can see this here. Actually neat oxidant is the oxygen, and generally air is used because atmospheric oxygen is atmospheric oxygen acts there as oxidizing agent. And by the way, in Walker process HCl is used, means acidic medium for this process. And whatever I told, that regeneration of palladium, you can see this copper 2 chloride regenerate this palladium 2 and itself got reduced, which further got oxidized using oxygen in presence of acid. So this is the overall reaction. Now, so what is the answer here? Simple. This position will be ketone, where it is given option D. Now, if this question appear on exam less than 30 seconds, how can you come up to the right answer? For that purpose, student, you need to look at this reaction condition. First, it's a Walker process, and second thing, it's a substituted alkene, so it will produce ketone undoubtedly. So D is the answer. Now second thing, if you still don't understand, how can you come up to the right answer? By the way, these reaction, did I used any acid? No. Even these amides are slightly basic in nature, so you can consider this not acidic condition. So acetal deprotection, ketal deprotection not possible. So obviously option A and option B is gone. Now what is the third case? Aldehyde or ketone. So based on this Walker oxidations concept for substituted alkene, you can see the product will never be aldehyde. I have explained in the mechanism, beta hydride elimination. So that's why D is the major product. Okay, so in conclusion, what you have learned today, that palladium is actually a soft metal, that's why it forms coordinate complex with alkene. Point number 1. Upon oxidation, alkene becomes electron deficient. Now, sorry, not oxidation, upon coordination, and obviously it is also a kind of electron donation from alkene's pi to palladium, and that's why this alkene becomes electron deficient. That's why nucleophilic attack on alkene became possible. Why? What is the fact, student? Alkene is electron rich because pi bond electron cloud is distributed, so it's the electron cloud there, and nucleophilic attack on electron cloud, simple alkene not possible. But because of this electron donation, there is a deficiency of electron, that's why nucleophilic attack on alkene is possible. In next stage, after this nucleophilic attack, there is a chance of beta hydride elimination by 4-member ring, and which produce enol, which undergo tautomerism to produce carbonyl derivative or keto, because keto is more stable than enol, means in and all, double bond and hydroxyl group. And during this reaction, palladium also gets reduced, because palladium hydrogen bond formation is nothing but reduction, which is subsequently oxidized by this copper 2 plus 2 palladium 2 plus, and copper got reduced, which is oxidized by oxygen in acidic medium. Now the last part is that reduced copper got oxidized. Okay, so as I told, oxidized by oxygen, and overall this is the Walker oxidation of carboxylic. So Walker process the catalytic oxidation of alkene with oxygen, which produces carbonyl compound. For ethylene, it's aldehyde. For any substituted alkene apart from ethylene, product is ketone. So this is the end of discussion. Thanks for watching this video, and if you really consider the content of my channel is worthy, then please help this channel to grow. So stay happy, stay blessed. See you in my next video. Bye bye.